Here we have one more set of general functions to integrate. So far, we do not have any method to integrate functions of this sort. That is why you were asked to derive formulae for these. Once they are ready, we can easily integrate functions of this sort. That means square root of polynomial functions. Somewhat like this. They all can be integrated by using those formulas. And to integrate these, you were asked to use integration by parts, where these are going to serve as the first function and one is going to serve as the second function. You all did the first question. I've done all three for you, and here is the answer key. You may go through them to check your first question. This is the answer for the first question, and the second formula is this, and the third formula is this. These are the three formulas altogether. So far, we have many formulae of integration, and we have to have way to memorize them for quick application. These three can be easily memorized by relating them to some of the old formulae, and these are those formulas. Here you can memorize these new one formulas by looking at the similarity and the difference between these known formulas. So in this way they'll be easy to memorize. As question 2, you were again asked to integrate the same general function as you were asked in question number 1. There you actually sorted it out by integration by parts, and here you have to make a trigonometric substitution. We are using x equals a secant theta. And why this substitution is so? See, the whole idea of substitution here is to get rid of this square root. We haven't integrated such functions before. Okay, so what are we doing? We are actually getting rid of this square root sign so that this quotient becomes simple. And to get rid of the square root sign, the trigonometric substitution is to be made, means it should be well thought of. Okay, see, this is x square minus a square. What should we write x as so that we get rid of root? That is a secant theta. No, just because of this minus sign we are choosing this secant theta. And why a? So that it get a square and that can come out of root. So first a, so that a square can be taken out of root, and then secant theta, so that the term inside the root is secant square theta minus 1, which is actually equals to tan square theta, and then that monomial can be taken out of root. Okay, and if you see here, here I asked you to thought of what trigonometric substitution you are going to make. Now as we have a plus sign here, so first thing we have to take a out of root. So x should be equals to a and something else also. And what is that else? Because this is plus, so that should be tan theta. So here we must substitute x as a tan theta. Okay, and the root will get sorted up, and then we can carry on our integration simply. Please go through the solution of question 2 and question 3. You may also do them yourself, and then you can check your work from here. Question 2 starts from here, and then it continues from here, and finally the last answer is this, which is similar to the answer obtained in the question number 1. This procedure actually involves integration of secant cube theta and secant theta. You have already derived uh, uh, integral of all trigonometric functions, so you are aware with the integral of secant theta, which is this, but I have done it again just for the recapitulation. This was the procedure involved behind this identity. And this also involves integral of secant cube theta, which is beautifully calculated by using integration by parts. And that's why I'm asking you to go through this procedure either yourself, or at least go through this attached PDF here, because this is an important concept to be added to concept map. Okay, and here is our third question. It also involves the same thing. So I'm sure if you these were the general question, and if there would be numericals based on uh, these these functions, they will also involve integration of secant theta. So it's better we must add them into our concept map. uh, so here I have listed few questions. So they all are square root. Here you can see square root, square root. This is also square root in a way. So they all are the square root of polynomial functions. So these can be integrated either by using the formula directly that is obtained in the question 1 or 2, or you may just do them with the trigonometric substitution only. Okay, so what are you going to substitute here? See, this is 64t square plus 1. Because this is plus, so this is of the form 1 plus tan square theta. Okay, but what should we let t as? Okay, so initially you can actually take 64 as common. Okay, so this will reduce to t square over 1 over 64. No, and then when it will become t square plus 1 over 64, then you can take your 64 t as 1 over 64 tan theta. No, t equals to 1 over 64 tan theta, and then you can proceed accordingly. The same procedure is to be adopted in the rest. Just have a try on them. Yes.